AGHAMAZING, my dear students! Welcome back to our science video lesson. I am your science teacher, Teacher Larry, and welcome to AGHAMAZING way of learning science. In our last video, we were able to define motion and describe using the concept of distance and displacement. In this video, we are going to describe motion using the concept of speed and velocity. Have you ever wondered why different objects travel the same distance, but they take different amounts of time? This is because some objects are traveling faster or slower than others. Aside from finding out how far did the object travel, we can also describe motion by finding out how fast did the object move from its initial position to its final position. This information can be provided by finding out the object's speed and velocity. Let us talk about speed. Speed is defined as the rate at which distance is covered at a given time, or it refers to how far an object moves in a given time interval. Speed gives us an idea on how fast an object can cover a distance in a given amount of time. It indicates how fast an object is moving without referring to the direction of the motion. Since there is no direction involved, speed is considered as a scalar quantity. Observe the speed of the two motorcycles. Which do you think will cover a greater distance in 5 seconds? The one that moves faster or the one that moves slower? You are correct. A fast-moving object has a high speed and covers a relatively large distance in short amount of time, while a slow-moving object has a low speed and covers a relatively small amount of distance in the same amount of time. An object with no movement at all has a zero speed. Speed is expressed mathematically as distance traveled divided by time. The SI unit for speed is meter per second. We can also express speed in terms of kilometers per hour and miles per hour. Before we have a sample computation, we need to understand the following terms. When we say instantaneous speed, it refers to the speed at any given instant time. And when we say average speed, this refers to the average of all instantaneous speed, found simply by distance-time ratio. You might think of the instantaneous speed as the speed that the speedometer reads at any given instant time, and the average speed as the average of all the speedometer readings during the trip. Let us take a look at this problem. A car travels 150 kilometers within 2 hours. Find the average speed of the car. To solve this problem, let us take down the given data. First, we have distance traveled by the car, which is 150 kilometers, and 2 hours, which is the time. Our main task is to find the average speed of the car. To solve for speed, we will use the formula speed is equal to distance traveled divided by time. Let us now substitute the given data. Speed is equal to the value of distance, which is 150 km, divided by the value of time, which is 2 hours. Solving this, we got 75 km per hour. The average speed of the car was 75 km per hour. When direction is associated with speed, you will have a new quantity known as velocity. Thus, velocity is defined as a speed in a given direction. That gives us an idea on how fast an object is moving and to which direction. It is a vector quantity. Velocity refers to the rate of change in displacement. Velocity uses the concept of displacement rather than the distance traveled and time. Velocity can be calculated by the change in position divided by time. Note that there are arrows on the symbols to indicate the velocity is a vector quantity. Speed and velocity have the same units. However, velocity requires direction. Let us try to solve the problem involving velocity. A sailboat is in a 1,000-meter race due north, and it crosses the starting line when it is already at full speed. It reaches the finish line in exactly 80 seconds. What is the velocity of the sailboat? Again, the first step to solve this problem is to list down the given data. In this case, we have 0 as the initial position because the sailboat is from at rest, and 1,000 meters as its final position. We also have 80 seconds as the time. Our main task is to find the average velocity of the sailboat. The formula for velocity is velocity is equal to final position minus initial position divided by time. Now, let us substitute the given velocity. Velocity is equal to final position, which is 1,000 meters, minus initial position, which is 0, divided by the time, which is 80 seconds. Thus, velocity of the sailboat is 12.5 meters per second north. And that ends our discussion on speed and velocity. In this video lesson, we were able to describe motion by answering how fast did the object travel using the concept of speed and velocity. In our next video, we will be describing motion by using the concept of acceleration. See you on our next science video lesson.